Hello and welcome to today OneLIMS webinar, Laboratory and Factoring One, Labtory, the future of food production. It's an honor for me to present or give an introduction to about our speaker today. Is called Professor Dr. Tilo Hühn from the Zurich University of Applied Science. So Tilo is a pioneer in food innovation. Tilo is a trailblazer for me in the field of food technology and innovation. With a background in process engineering and food technology, Tilo has carved out a remarkable career marked by significant achievements and contributions to sustainable food productions. Some of his milestones are academic excellence as a PhD in process engineering and food technology, showcasing his deep expertise and dedication to advancing these fields. Leadership at the Zurich University of Applied Science as a Center of Food Innovation leader at this department, spearheads cutting-edge research and development and food technologies. Also, some food ward projects, activity involved in Food Ward and other organizations which aims to revolutionize the food sector through interdisciplinary collaborations. Some of the other milestones in industry collaborations, like extensive work with industry partners, had led to successful implementations of innovation food production technologies, which have had a tangible impact on the market. Some of the names like Oro de Caco or Renat as a startup, maybe we heard some inputs from Tilo from this startup, Pâtis Suisse, Berry Galabo, and so forth and so on. And Tilo has a hard project. He is a wine connoisseur and enologist, and discover kind of the expertise in wine. So Tilo's visionary approach combines scientific rigors with practical applications, drive the food industry toward a more sustainable and innovative future. His work not only pursues the boundaries of food technology, but also inspires a new generation of researchers and industry leaders. So welcome, Tilo Hühn.
Hello, everybody. Nice to meet you. Thank you, Philip, for the warm introduction. And I'm happy to contribute today some thoughts from our idea and realization on Labtory design.
Thanks very much. So first of all, some general information. We record this webinar and we will bring it on demand in the next 2 days, so it can be reviewed over and over again on our YouTube channel. If you have any kind of questions, type them directly into the chat of this webinar, or if you want, you can ask your questions at the end of our today's webinar in the Q&A session directly to Tilo or to me. If you want to have the presentation slides from our side or the slides from Tilo, just send us a request to hello@onelims.com and we will provide you the slides presentation for you. So let's hop directly into today's topics. So Tilo will start with the Labtory concept overall and give his inputs and expertise about this topic and concept. Afterwards, we will look into a very brief overview about challenges in the food quality control, and we will discover the benefits and added value of a smart Labtory production site and what does it mean. So I will hand over to Tilo. So the stage is yours. can see your slides.
But we cannot hear you.
You are muted, Tilo. Sorry.
Can you hear me now?
Yes, I can hear you loud and clearly.
Very good. And you see
yes,
the bubbles moving. Yeah. Hello, everybody. Tilo Hühn, as introduced. Today, I'm broadcasting from our little family winery in Rüdesheim am Rhein. And I'm happy to share some thoughts on exponential food technology and Labtory design with you. You are informed over media day by day that we live in a polycrisis. And this polycrisis influenced the environment for especially the sourcing of raw materials which are processed by the food industry. One of the biggest challenges in the food industry today, from my point of view, is availability of raw material, the sourcing, availability of workforce, availability of technology, of solutions with which fits to our new challenges. Besides that, we have to manage a high amount of food waste, which is produced, for example, in Switzerland, 170 kilograms per head per year is wasted. By seeing all the influences by climatic change, it is absolutely clear that the composition of our raw material will differ from lot to lot, as it was and is since decades, but these differences will increase. Therefore, we have to find other solutions to manage the different composition of the raw material. And one of the solutions we developed is this Labtory concept, changing from batch processing and standardization of the raw materials, which could be used for our recipes, to continuous working concept, which is data-based and based on the classification of the material, where we can adjust our process, especially continuous working processes, to fit the expectations of the customer for an optimal product. So reducing the amount of raw materials which will be rejected by our relatively static quality management system. This is one part of the background. We developed a view on that. We call it food architecture. You can share the presentation, Philip, to the attendees. David Schildberger, who is an architect from Vienna and ETH Zurich, worked for more than 4 years in my group. We collaborated with Ludger Hofstad from ETH. He holds the chair of computer-aided architectural design. You can ask yourself, what has that to do with food? A lot. The architects, they are dealing not only with building and constructing, they are thinking about all the circumstances, the structure of complex systems to build infrastructure and to live on, at the end, on that planet, to organize living on that planet. You can find links in my presentation. Here is the PhD thesis from David. Today he's working for Strabag, a well-known company, and he's head of the data science team, so changing from food again into construction. There's a book publication. Yeah, it's really an epic work, let's say. This builds the foundation of our philosophy to get a holistic view on it all. One point I want to make in my presentation here is that we should change from the mindset of value chain. Everybody is talking about the value chain, and the chain creates some big challenges, because delegating some responsibility and at the end guilty on different parts of the chain leads finally to the situation we are in today. So the pressure on the primary producers is high and growing. The margins are low. We made food safe and available, not for every region in the world, but for the Western world. And at the end, the system in some parts, and you know, that is ruined by applying this chain mindset. We can use information technology to change from this chain mindset, so food on chain, I call it, to a network view, because the informations are available. Not all informations are correct, but installing some instances and using some technological tools, like perhaps blockchain technology, could deliver transparency, and it will be possible, if we act transparent, to get some trust from the customer back. If we want to have a system which respects what's going on that planet, when it comes to sustainability or regeneration, we have to have some transparent informations that people who can pay for it will pay for it. So at the end, it could be a solution if the values on different levels are respected. My dear partner and wife, Gisela, and myself, we published some articles around the planetary health diet and all the circumstances and the impact on food production. You can find here different links. It's available in German and in English. The last one was published some months ago about exponential food technology. So if you want to more deep dive into the topic, I would recommend episode 6 and episode 5, Pixels, Plants and Processes, how we think on possible solution. Yeah, besides what's changing, influenced by the climatic and the loss of biodiversity and the overusage of resources is for sure, and we are more or less all in the age of digitalization. I wrote an article and I ask you really to give me feedback on that. This is a vision. I hope it comes to a good end, to this environmental turn where we use all the informations and automation for good to save life on Earth, and at the end our lives too. But we know that there is a dystopic challenge which could arise by what people called artificial intelligence. I'm not so happy with that term. I prefer machine intelligence, but I will talk a little bit later on that topic too. So behind our abilities to develop new processes and all the technological setups, we have to develop our mindset to be ready for this, what is happening now. And this mindset topic, I think it's for the Labtory concept and exponential food technology. I will talk about really important. So we are focusing in my research group and with our applied project on mainstreaming all streams. What does that mean? If you treat a stream as a waste stream, imagine that, you call it waste stream, I think the error begins. We have to respect all the streams. Even if you talk about side stream, the mindset is another. If I choose the term mainstream, all streams. I value, I respect all the streams, and I will give you some examples what that means to us. Extracting, separating, preserving more of the valuable, transforming the natural composition into valuable products, using this view on value networks, creating signature taste, nutritional functions, beneficial business models, and contributing to planetary health. If you ask me what are the big topics arriving in the food and nutritional system, I would say it's really longevity and health. And not only for us as humans, for all living forms on that planet. Yeah, this Labtory concept I started to explain. It's a combination between laboratory and factory. And we want to use modern data systems. So IO-Link, for example, in the back in Rheinbach, we installed more than 6,000 data points. And we have the possibility to do real-time computing, edge computing to use the data which are produced continuously via different sensors and creating some sense out of it. Creating meaning using machine learning, this is what we want to realize with that Labtory concept. You can't do anything with it, for sure not, but we know that different customer groups prefer different products. You can measure that, you can ask them, you can look for their preferences, you can do some sensory evaluation and aroma analytics and polyphenols and so on, all the data. Then we are applying that data as reverse engineering on the process. And at the end, the final goal, and we are not there, we are on the way to do so, the final goal is that we can manage differences in composition of the raw material, for example, cocoa beans, to adjust all the process parameters. We can do a lot, not everything, as I said, but in our case, we can reduce the content of acetic acid. We can manage some other ingredients by adjustment of process parameters, temperature of the water, overall milling degree, maceration time, separation strategies, and so on. So our idea is moving from batch to continuous working process, moving from standardization to classification, to extract more of the values of the raw material. In the case of cocoa, we started 2006 with observations in Venezuela. You can find here some research articles. As a wine grower, I know the impact of acetic acid. Acetic acid in a concentration over 0.5 gram per liter in wine masked all the beautiness of the other primary flavors and the fermentation flavors too, because this component, this acid, is volatile. In balsamico, this is nice, but in wine, we don't want to have the acetic acid. And the same effect occur in cocoa. There, you can't prevent it. If you do a fermentation, first you have a formation of alcohol from yeasts, and then acetic acid bacteria transform the alcohol into acetic acid. So this is an inconvenient truth. All the cocoa beans are more or less spoiled with acetic acid, which brings us to the fact that high cocoa concentration in the end product shows a high concentration of acetic acid. You can't bring the acetic acid out by roasting it or conching it totally. It's not possible. With our treatment, we can reduce it around 80% mass by mass. So in every case, under the aroma threshold. And there is another important point. This acetic acid makes the chocolate more tasting, not only sour, it tastes bitter. It's a bitter booster. And that is the reason why cocoa with high, chocolate with high cocoa content is not so really loved by most of the consumers. If you look for the sugar content of some chocolate, it's partly, when it comes to milk chocolate, over 70%. So this was developed during the years, and Dieter Meyer invested in that technology. And now in Freienbach, we built up the first, we call it Labtory. Here you see part of the team. That was during Corona. Now the Labtory is up and running. The overall total capacity is around 5,000 tons a year, which is not reached so far. To present that this is a special chocolate quality, a brand was established, and yeah, you can find them on the net and in different formats in Switzerland. But the main focus is on the other streams. For example, applying the conventional process of cocoa processing, you will destroy by the high energy input and temperature by roasting and later on the conching over a while and high temperatures. You will destroy catechin and epicatechin, most of that. And we got really concrete amount out of the cocoa by doing the extraction with water at low temperatures. And this stream is really valuable. It depends on the concentration and on the purity. The value of 1 kilo is 10 times to 50 times higher than the defatted cocoa powder. So from our point of view, we want to get all the elements out of cocoa. Besides this polyphenolic antioxidant extract, the cocoa powder, the cocoa butter, and the aroma from the natural fruit. But if you look for the value, these substances which are destroyed during processing in conventional ways is the most valuable of it. So an ingredient which was destroyed before was saved, and now we can use it by applying continuous processing technology, and now we go a step further to optimize, to self-optimize the system using machine learning. This is the case of Oro de Cacao. We developed the same for coffee with my dear innovation partner, Roland Laux. The idea arrived in 2006 in Venezuela for cocoa. I had no clue that time about cocoa processing, but sometimes it makes absolutely sense to have no clue of somewhat to rethink it from the beginning. And we did it for coffee too, and we did it for spices and herbs too. Spices and herbs is really interesting too. We produce an essence, oily essence. This is not new, but what is new in that application is that we start with fresh herbs or with already fermented pepper. And pepper is a really good example. Using the pepper after fermentation and mill it directly with plant oil, you can have some ingredients in double concentrations, others tenfold, others hundredfold, others thousandfold, and there's some substances 10,000-fold higher than if you dry it first and make it then as an extract with oil or apply it dried. So drying means in any case a big loss of some special ingredients. The latest development in that direction, Philip mentioned it, is renut. We were traveling in different regions of the world and doing innovation projects for startups or for the biggest players. And we were 2017 in Ordu, close to the Black Sea in Turkey, and we visited hazelnut production and did some experiments on hazelnuts. And yeah, at the end, making a long story short, we came up, why not using the whole nut? We did some applications for chocolate spread, for example, usually 52% sucrose in the market leader recipe, and 13% of the kernels. We use 26%. This is rough, the amount of the hard shell, 50%. So 26% of the whole nut, mill it down to the ground. This is what we learned with cocoa processing. If you mill it really smaller than 30 or 20 micron, you have no sandiness further on the tongue. And this is very cheap natural filler. We reduced the sugar content by this 13%. And at the end, the tasting were very interesting. So the feedback of most of the people was, we tried that in Kitchen Town in Berlin. Christian Zimmermann did that, our CTO, that they like this recipe better than the established standard. But we will see. It's high fiber. For sure, it's a little bit more. It's a little bit less unhealthy, let's say. It's not more healthy. Who can claim that chocolate or chocolate products with so much sugar are healthy? But we replace some sugar with the hard shells. And we have two processes patented in Europe and pending in some other states. A wet processing is shown here. We mill the whole nuts, not only the kernels, the whole nuts with water in a ratio. Then we get first out a drink. You can get out parts of the oil if you want. And then we have some solids containing still some fat, but reduced fat amount. And you can use these solids for application in bakery or, as I said, chocolate spread or such things. And if you compare the price for the sugar, which is in most of the cases the cheapest ingredient, this is the reason why we're using it in food production. If you compare the price for the hard shells with the sugar, it's absolutely clear that this is an application which is bringing additional value in the network. And at the end, we have opportunity to enrich fibers. We all eat too less fibers. So the German and the Swiss nutrition community absolutely point that out, that we only consume 15 grams per head per day, and we should double it or triple it, and we should eat more nuts and less meat. Yeah, we found another way to manage this acetic acid problem. Two other ways, to be honest. I only want to speak the limited time about the cell culture thing. If I see a brewery, I think on a culture media production. So this is the next thing. We can use streams for feeding plant cells to produce foodstuff. Everybody is talking about meat. We are talking about plant cells, and these two guys are the pioneers of it, Regina Eibel and Dieter Eibel, and we started to do plant cell cultures for food in 2004. They started to do plant cell cultures for other reasons, cosmetics way earlier, and for pharmaceutical applications, since the 80s of the last century. You can find an exhibition in the Home of Chocolate. They honored us, and in the Museum of Chocolate in Cologne. This feels a little bit crazy if you are in a museum during lifetime. So we were the first group who applied that techniques, starting with beans and propagating it to bioreactor using culture media. We're on the way to do a big project with a Swiss partner on culture media, which is Clean Label. And we continuing thinking on that application. This was the first work from Sylvie Couperos on grapes, 2007 published. You see here different other cell cultures. The way we go was we take the whole pot, then there's a hygiene step, and then we herd the beans. So there is a callus production at the wound, and these callus could be propagated. This takes plus minus 6 months. And if you are in that stage of continuous development of the cells, you can harvest after inoculation every 2 weeks, let's say. So far, no fat production. We found some ways to stimulate that too, but this is under research. You can find in this presentation here some links. There's a nice video. You can see how we do that. And the next big thing is avocado. I don't know if you know, the circumstances for production in South America are really bad. 1,000 liters per kilogram avocado drinking water is used. Then the avocados fly to Europe. This is the inconvenient truth. And with our cell culture practice, we can't produce a whole avocado, but we can produce the slurry, and this will be used for guacamole. The water usage is tenfold less, so around 100 liter, including per kilo, including the culture media production. And culture media costs and costs for the technology the same. This is an exponential technology too. When it comes to fermentation, it's like that, it's exponential. And using this data-driven system is more usual in pharmaceutical applications and in this biotechnology applications too. So it's absolutely clear that we will follow that road, using technology to manage these processes right, and to develop them further by observing patterns which are not observed before. To come to an end, I put some informations together on this one slide. I think the most important one is written down in red. It's the cultural shift. You can't continue with people thinking in the past. You have to develop a mindset with the people who are able to accept and adapt the data-driven structures, not only in production, in everything what we are doing, marketing and so on, but today it was a focus on production. This is not easy. Yep. You know for sure the famous Peter Drucker. He said, culture eats strategy for breakfast. You see on the coffee cups, there's mindset written. I add that. He for sure included that in his thoughts. But this is really from utmost importance from my point of view, that beside the soul set, which is special to the mindset of the people. And you can, I think it's not easy to work on the soul set, but it's not easy to work on everything, but you can perhaps with the arguments find a way to develop a common mindset, which makes it possible to apply modern ways of thinking when it comes to exponential solutions. To make that clear, it's not enough to do our process engineering 10% better, 20% better, 30% better. This is not enough. If we want to regenerate a part of the system which was destroyed by us, who is us? But I see that as one important goal for my work, professional work, that we have to develop processes where regenerative thinking and all the things I talked about are built in. So this is my contribution. I try to do that as a commonpreneur with my team for having some positive impact on the overall system. Yeah, this is the definition of exponential food technology. I don't want to repeat that. That's it. Thank you very much for your attention. I'm happy to answer some questions.
Amazing. Thank you very much, Tilo. It's very impressive information and also inputs. Some of them I really surprised. 1,000 liters fresh water for 1 kilo avocado is really bad. Even then the transportation and all of that, if we calculate it within. So I want to start with the Q&A session, also related to the time. My first question is, you showed some factories were ground up built with this Labtory concept, like Oro de Caco you mentioned, or even Rinat. If we have a company, they have already a production plant. What's the first steps and what's kind of the biggest challenges to implement and start thinking of all streams are mainstreams and to implement this Labtory concept?
Yeah, I think as I ended, the mindset is the most important one. And you know that better than myself, Philip, honestly speaking. You implemented a lot with your first limbs. And you talk to the people and you know that some of them are really open for new things, others are really defending their existing system. And all of them, I think, are working with Excel, and nothing against it, but this is the past, and it creates a lot of errors, and it creates a lot of confusion, and a lot of work. It's not bad. It was the last solution. The next solution will be automation, and for sure, artificial intelligence creates some errors too now. But prepare the people for applying that technologies. Some people are not trusting themselves, so distrust to these tools is a good idea. Check it, but automation, everything which could be automated will be automated. I'm sure about that. And the base is creating a mindset for it. This is critical thinking. This is absolutely professional thinking. And then look for the opportunities. And then all the points I put on the one slide. You have to have a proper system of computing. You have really a stable system for manage all the data. This is expensive for sure, and this was applied so far in biotech for pharma products, but not in food. And I think this is the next step. There is a big investment, and I'm grateful that I found some people who trust in our work, that they invest in such structures. But at the end, if you see the possible values, I showed that out with these catechin and polyphenol extracts and other things with the hard shells. This is a value. A colleague of mine said shortly, Tilo, understand it right. Do I understand it right? You have double the mass without planting any tree more. Yes, this is it. This is exponential. This is big. And there is a chance. But there was another question, I think, from one of the audience.
Patrick Geiger. I can read
kernels, yeah. You know that there's a big selection, and these all purification and cleaning and deshelling and so on. So part of it we need it. Other parts are not needed anymore. We respect that point in our patent application. There are some possibilities to clean the surface by spraying hard shell materials on the surface. So far, we had no detection of any heavy metals or residues from pesticides or mycotoxins. At the end, if there is an insect in such a kernel, if it could not be selected before, I think by milling it, the chocolate spread doesn't show if there is some insect protein still in it. So this is another point. If there is a risk for the customer, we can put that not 100%, but very in a high amount as expected in the food industry out. But at the other hand, there are so many side streams today, or waste streams wasted, and we can use them for really good products.
Good point. Thanks for the answer from the question from Patrick Geiger. I wanted to continue with the question. So we talked about new food production technologies, and from the end consumer perspective, what's your impression about the changing of the nutrition and health of these new innovative food production technologies? Are there any kind of changes in our nutrition and food, how we know it today?
Yeah, I'm sure there's a big impact from the countries where wealth is growing, and this is for sure a big difference. If you buy food only for fill your hunger, and you are limited in the availability of the money you can spend on it, it's another question. But in the more developed economies, the point of getting the right food, healthy food, perhaps with less negative impact to the environment, such points are really important. The latest one is for sure longevity. People want to live, some very rich people want perhaps to live twice or forever, I don't know, but they dream on loading up and cloning and download again. Some people are doing so, and others. So let's say the average people, they want, with average availability of wealth, and they want to live longer, and we do. And they want to have a better life, and we do. They want to stay fit and be nice, be a beauty. Yeah. So the target group is clear, which is behind that. So look for the supplements, and look for the supplements which will arrive, touch the market this year. Yeah, there will be some on it. Not from our side, but look for it. There are some new products, OTC products, over the counter, for health and beauty supplements will arrive. So there was a discussion, I think, during the last 20 years about the big players in food industry and the big players in pharmaceutical applications, that the one part is going into the other direction and the other way around. So this nutritional thing and individualized food will really grow. But to be honest, talking with some medical doctors about individual medicine or nutritional specialists, we are at the beginning. So the exploration of the health when it comes to the topics like microbiome and so on. These are at the beginning, but there are some breathtaking observations. For example, and the newest hypothesis I heard from some colleagues from Erlangen, they did really serious studies on Parkinson, and they found that the markers for these protein markers for Parkinson, which produce these motoric problems, shaking and so on, could be detected in some regions in the brain for sure. But before, you can find them in the vagus nerve and in the intestinal system. So it's most probably the way that there is an impact from the intestinal system and the microbiome on neuro diseases like Parkinson. And if you go back, they did that to 1807, where the first diagnoses were made, and there were some observations around the microbiome. They don't know the microbiome, they know the gut, around the gut. And this is important, by our specialization. We focus only, so medical doctors for neuro diseases, they look to the brain, perhaps a little bit nutrition and so on, but the brain, and not the gut. And this has to change, and think about what that means for us in other applications too. We have to develop, not alone, this is not possible, but in collaboration with others, a holistic view on some challenges.
Very, very interesting. Let's remember me on the book Stahl mit Schaum. I think it goes in that direction. Also the saying, I have a gut feeling.
Yeah, perhaps in the new presence, the artificial intelligent co-pilot have a gut feeling. This is the other part. Today the structures, how these tools are programmed, are clear, but how they function in detail, this is not estimated, and this is not possible to really understand that. I think we have to really take into account that this is one step in history with what happens now. So this large language models, this is fundamental what is going on. When it comes to learning, look for that Boston Dynamics movement of these robots. This is deterministic. This is programmed. But if you look for application of some APIs from LLMs on moving robots with only installed computer vision, a year ago, they need 2 days to find the orientation in a room. Then 6 months later, it was only 2 hours, and this is exponential too. So today it runs so fast that these tools and tool is the wrong term. Again, it's not a tool. If you have a hammer, you can treat everything as a nail. But it's an instrument. It's an instrument. I think this is important. All the people are talking about tools. For me, it's an instrument. If you can hear some people playing a violin or so, and it hurts you, you get some headache, and others playing the violin, and you start crying because it's so nice. And this is the same for these new opportunities with LLMs. It's not a tool, it's an instrument. Some people, and it's only for the skilled people, sorry. If you ask stupid questions, you will get for sure stupid answers. And if you ask intelligent questions, you have to really critical think on the answers. But you can have really new and marvelous insights.
Thanks for that explanation. I have the same impression. So by using those instruments, there is a high potential of get misused and then misleading solutions or answers, rather than to have more potential answers that brings you on the right track and gives you the correct and explicit specific answers to your problem. I think there's a big gap in between.
Absolutely.
Thank you very much. Do you want to add anything? Otherwise,
No, thank you. I'm happy that you attend that and you recorded that. I want to ask for feedback. Yeah, please contact me. Please share your thoughts on our thoughts, on my thoughts. Prove me wrong. I'm happy to interact and to develop the ideas further. And I'm sure you will see some applications outside in the next years of our Labtory solutions.
nice. Looking forward to. We'll keep the eyes open and very curious about how to establish or how long it takes to establish this Labtory concept in even bigger players and get more traction in the market.
Thank you, Philip.
Thanks very much. So I propose also related of the time, I would propose to have a second part of this webinar topic together with you as a speaker again, to deep dive in the most potential technologies, or even to have a Q&A session with you. Is a lot of valuable insights and information for me, and I think also for all the attendees, to have the opportunity to do a second webinar with you as a speaker. Would be amazing. I want to close this webinar very quick to give an outlook to our next physical events. We'll be on site at Swiss Automation in Rapperswil. Will be the 12th of September. We'll be there with Aurovis, which presents automation, industry automation for laboratories, for high sample throughput. And also we will present our lab execution system called Lab Pilot. And if you deep dive or want to deep dive and get more information about laboratory and quality control, digitalization, and what's the added value and the benefits out of it, you can check our case studies out of the food industry and material science. And if you want to know your actual health and fitness of your laboratory digitalization status, take 5 to 10 minutes and answer 15 questions within our quick lab check to evaluate and determine your actual status and get an action plan from our side with action steps and also improvements potentials from your operations, data streams, and connectivity. With these words, I want to close today's webinar. I want to thank you again, Tilo. It was a pleasure to have you on the webinar. Thanks very much for you sharing your valuable insights, and looking forward, hopefully, to have a follow-up and a second webinar with you on board. Have a good one and wish you a great day.
Thank you. You too.
So